There's one programming concept that nearly every company utilizes, especially larger companies, but almost no developers landing their first job have even heard of this, let alone actually understand how it works. And this is the idea of background jobs or a job queuing system or something of that effect. And in this video, I want to go through a bunch of different diagrams explaining how these different systems work, as well as showing you actual real world code of how to write your own job-based queue system for scheduling jobs and so on, so you can understand not only how these job systems work, but also how to build your own. Welcome back to Web Dev Simplified. My name is Kyle, and my job is to simplify the web for you so you can start building your dream project sooner. And before we dive into this complicated diagram of the implementation of all these different queues, I want to first talk about the whole reason why we have job queues, because that's one of the most important things to understand. Let's take a look at a normal web request. It doesn't really matter what this is, but let's just imagine someone is making a request to our server and we're sending them back some information. Let's say, for example, they're submitting a form. Well, inside of that request, this blue bar for our request represents how long that request takes to get all the data and send it down to the user. And below that, I have the request broken down into all the steps that is taken. It's a very simplified version, but essentially, let's say that we take the information that they send to us from their form and we save it in the database. Then we render out whatever HTML they need based on that information and we send that down to them. And finally, we also send out an email, maybe to like a moderator, to let them know that this new user has posted a comment, so the moderator can come and make sure the comment's good and they can approve it and whatever else. As you can see, this is the total time that this request takes. But the only information we need to do to actually send down the HTML to the user is these first two steps. We need to save the information in the database and render the HTML. And depending on our application, we may not even need to save the information inside of the database before we send down the HTML to the user. But generally, you're going to have your database work and your HTML work, and then any extra things like sending out an email or maybe saving information to like a file-based system, all of that stuff should be happening at a later date. We shouldn't have to wait to send an email to the moderator before we go ahead and actually get our request. So the whole idea of background jobs is we take those extra things like sending an email and we remove this from our request. And instead, our request is now much shorter. As you can see, we drastically reduce the amount of time to send a request back down to our user. And instead, we take this send email, we shrink this down, and we package this up into what's called a background job. And we put this inside of some type of system that'll process these background jobs at a later point in the background whenever our server is not handling requests for users. This means that things that aren't urgent for a user to get their information happen in the background, which makes our server faster for users. And it also means that certain things like sending an email, if this failed for some reason, it doesn't make our entire request fail. Instead, this job will fail and then reschedule itself later. So let's take a look at what that job system could look like. You can imagine the program right here is our web-based server, and we have a request that comes in that asks a user to send a particular email. Like we want to send an email as part of a request. So what do? Well, we take that send email from our program and we add it to our queue of jobs. So it would go directly inside of here as one of these different jobs. Then later, this could be an entirely different server. It could be the same server. It doesn't really matter. Something else is working on these different jobs. We call it a worker. And what we do is we just take a job from this queue, whatever the next one is, we put it in the worker, and the worker is going to do some work, finish that job, and then boom, get rid of it. It's going to be completely gone. And then it's going to take the next job, boom, work on that. Once it's done, delete it, move down the next job, and so on. And we can have as many different workers as we want, so we can scale this system up and down based on the amount of jobs we have. And if for some reason, like this job actually fails, well, we can just go ahead and put it back into the list to try to re-execute at a later point because maybe the API we were accessing is down or something. And as you can see, we're constantly going through all of these different jobs one by one, slowly getting rid of them. And when we get to this send email, for example, we try to send the email. It can wait as long as it needs to. It doesn't matter how slow it is. It's going to be working on this in the background. And again, if it fails, boom, we just add it right back to the queue. This original request still succeeded for the user, and we just wait and try this again to hopefully make it succeed in the future. So this is a relatively straightforward look at how this queuing-based system works, and now I kind of want to dive more into the actual implementation of how this works. So let me just bring over some code real quick. Here we go. And this code is going to be doing all the stuff for our queuing related information. The most important file for us to look at is this index.ts file, because this is the file where we actually use the queue, so we can understand how it works before we start diving into the actual implementation details of this queue. So as you can see, what's happening is we're creating a Redis based queue. Generally, when you're using these background queues, it's either going to use a database, or more likely it's going to use something like Redis or another really quick in-memory database so that it can really quickly get the information, save the information, whatever it needs to do. Then you can see we've essentially connected it to a database and we give it some name that we want to give it. Then we're just adding different jobs to the queue. If we look at these jobs, it's relatively straightforward. We pass along some data. In our case, we're going to be trying to send an email. So we would just say the email is the email we want to send to, and here's the body for the email we want to send. We can give this job a name so we can reference this job later inside of our system, maybe view what's going on. And we can even prioritize the job. So we know what, okay, sending this email is really important. We're going to give it a priority of 1. And you can add a bunch of different jobs. As you can see, this one has a priority of 3. So it's actually even more important because the priority is higher, and we have a delay. So we're saying, hey, only do this after a 1 second delay, essentially 1,000 milliseconds. You could implement this delay however you want, but it allows you to schedule jobs for the future. And we have a bunch of different jobs that we're doing all these different things inside of, as you can see here. Then we have a worker. A worker essentially hooks up to a queue. As you can see, we've connected this worker to a queue, and all the worker does is whenever it has a chance, it takes the next job inside of our list, it gets all the information, so as you can see, our email and our body, and it performs something on that job. So it takes all of this data and it does something with that data. In our case, we're calling this send email function, which is going to send that email to our user or to our moderator or whatever we want to do. Our actual implementation doesn't actually do anything. We have this case here where if the body is equal to error, we throw an error so we can simulate what errors look like, how we can do job retrying and so on. And we also return a promise after 1 second that resolves, essentially just saying, hey, this email took 1 second to send so we can test asynchronous code and all of that. So essentially to kind of recap what's going on in all these different sections, you can see that we have a queue that we create that hooks up to some type of database, in our case, Redis. We then add jobs to that queue wherever we want. You can see, for example, this job is being added after a 2-second delay. So we have a lot of different things with adding jobs and so on. And inside of our server, for example, where that user is making that request, we're saving the information to our database. That is where we would call queue.addJob, and we would add a job directly to that queue. Then somewhere, it doesn't matter where, it could be a different server, it could be the same server, it could be an entirely different process. We have a worker that's running connected to the same Redis database by this queue. So you can see here, we have that queue right here. These jobs are being added to that queue, and then we're coming in here with that worker, and we're just essentially taking the next job in the list. We're executing it, and then we get the next one, and so on until the list is empty, and then we just wait for a new job to get added to be able to process. This allows us to mean if we have a lot of jobs come in all at once, we don't overwhelm our system because we only process as many as we can. And if we have no jobs, it just waits until the next job, so it's not doing a bunch of, busy work. And the nice thing about these systems is if you want, you could have multiple different workers that are doing similar things with your jobs, or you can bump up the concurrency. For example, we can have a concurrency of 5, which means we have 5 tasks that we can accomplish at one time with a worker. So this worker can accomplish 5 jobs at the exact same time, so it can work on 5 things at once. So let's go ahead and just bump down our concurrency to 1 so we can really see how this is actually working. And I'm just going to run this particular file. We'll just say npm run dev. That's going to run this in the dev environment. As you can see, it's starting task 1, then task 3, then task 5, task 2. This one is the error one. So as you can see, it errored out and it started it again, errored out, started it again, errored out. And it's actually going to retry on a longer and longer period. So after every single time that it retries, it waits longer and longer to do that retry. In our particular code, we don't have the retry timer very long. It's only 1 second, and we only have a maximum of 3 retries before it completely fails and doesn't attempt anymore. But you'll notice if we look at the order, we started number 1 first because that was the first thing that got added into our queue. We then moved on to task number 3. And if we look at that one, that is because of the way that our priority system was set up. You can see this had a priority of 2. That was the highest priority that was currently inside of our system. Next, we moved on to task number 5, which you can see here has an even higher priority of 5. But the reason we didn't start this one until later is because it didn't get added to our queue until 2 seconds later. So it got added later, but it had the highest priority, so we started that one next. Then we go to job 2, which had a delay on it of 1 second. So you can see that this one was delayed to execute until later, and it had a high priority, but not higher than this priority of 5. So it executed later. And then finally, job 4 was the last one we did because it had no priority at all. So it was the lowest priority thing in our list. So as you can see, this is how you essentially would use a queuing kind of job-based system. But now we want to understand how this actually works behind the scenes, because I've given you the high-level overview of how it works, but the actual nitty-gritty of how the individual code works is actually quite complicated and really interesting to take a look at. And by understanding this, it not only will help you to use these systems better, but it will help you with building out software in the future, because it will just give you a good idea to understand how these complex systems work. So inside of the system, we have essentially 3 different parts. We have the queue, we have the worker, and then we have the job. Now in my system, I made it rather simple, and the job is just a TypeScript object. As you can see here, it's just a type. There's absolutely no class or anything built around it. It's as simple as it can possibly be. In a more complex or real world system, you would probably have this be like a full on class with a lot of different properties and so on. But for us, it's as simple as it can possibly get. Now, our worker is also relatively simple. In pretty much any system you use, the worker is going to be very simple because the only thing that the worker does is loop through and process different jobs. And then finally, we have a queue. In my particular system, I made my queue essentially an abstract class, and then I implemented a Redis adapter on top of it. And if I wanted to have like a Postgres database adapter, all I would need to do is just take this queue, implement my own version of it that processes these particular functions, and it's going to work fine. So this allows me to be super expandable to be able to use with Redis or with Postgres or any other system out there. In my particular case, I only built out the Redis one though, because that's the most real world scenario you would run into, because Redis is very popular with queue-based systems. So the very first thing that I want to look at is going to be how our worker actually functions, because this is the simplest aspect of our entire system. As you can see, inside of our constructor, we're passing it in the queue that we want to do work on. This is essentially the list of where all of our different jobs are. The next thing we're passing in is a function that we call with the job information to process that job. And then finally, we pass in any options. In our case, the only option is concurrency, and we can set that to any value we want. By default, it maxes out at 1. But if we wanted, for example, to come in here and we set a concurrency of 3, and I open up the console so we can see what that looks like, you can see it actually starts 3 tasks at once. So you can see it started task 3, 1, and 4, and then it went through it, repeated 4 a few more times, and then we had 2 and 5 down here as well. So as you can see, it's running multiple tasks at once because we have our concurrency set in such a way, and we can configure this however we want. Obviously, a higher concurrency would require more CPU and processor power, so you need to have a more powerful server you host this on. Going back to our worker though, this is relatively straightforward. Let's take a look at our start function, and the first thing you'll notice is the entire thing is just wrapped in an infinitely looping while statement. And this is something that's maybe a red flag to you because this is essentially an infinite loop, but inside of this system, it's perfectly okay because we're making sure that we wait until we have our next task before we process any further inside of our loop. I'll show you what I'm talking about in just a second. It's this function right here, get or wait for job. What this will do is it'll get the next job in the queue, which will be great. It can run all the rest of our code. Or if there are no jobs at all, it just sits here and waits forever. It will literally never execute any further until a job is added to the queue. So this means that essentially our worker is completely paused until a job gets added to the queue. Then when a job gets added to the queue, it runs through the rest of this code. Now this very first if check right here is just a failsafe. If for some reason this get or wait for job fails, or it like returns even though there is no job, this just sets up a 15-second wait where all it does is waits 15 seconds and then restarts our loop again. So it's just a failsafe in case something goes wrong and we get out of this without actually getting a job. This will just make sure we wait 15 seconds. That way we don't keep hammering this over and over and over again repeatedly, which would obviously be not ideal. Now, in the case that we do have a job, then we execute all of the rest of the code inside of here. Pretty much the bulk of all of this code is just this one single function where all we do is we take our active job and we set a job. And this active jobs, if we look up here, is a map that maps an ID to a particular promise, essentially just the function right here for processing our job. So all this is doing is taking our job ID and mapping it up to whatever that job returns for our information. So as you can see here, we're setting the job ID to executing process job. So we call process job and pass in the job. If you remember, that's just this function right here. So whatever function we pass in, we call that function with our job. And then if we have an error, we're going to handle that particular error by re-adding the job. I'll get to that in just a little bit. So we'll minimize that down and we'll focus down here on the finally section, which all I do is once it's done and it actually executed properly, or even if it failed, I just remove this from my active jobs. So I make sure that if I have a job that's running, it's in my active jobs. Otherwise, if I don't have the job running anymore, I remove it. Finally, at the very bottom here, if my active job size is greater than or equal to my concurrency, all I do is I make sure I wait for any of my jobs to finish and then I rerun my loop. Essentially what's happening is once I've filled up, so if I have an equal number of jobs as my concurrency, I can't have any more jobs, so it just waits right here until one of those jobs finishes. So once one of those jobs finishes, well, now this value of active jobs is less than my concurrency, this promise finishes, and it loops me all the way to the very top here where it gets a brand new job for us to execute. So this just makes sure it follows our concurrency issues where we only have the maximum amount of jobs possible. Finally here, this is the retry logic essentially. So if for some reason our job fails, well, I want to take my queue and re-add that job. That's the same function that we used out here, queue.addJob. I'm going to be passing in all my normal job information, and this stuff down here is just to make sure that we retry things properly. So if we really quickly look at my types, that'll actually give you a little explanation of what's going on. Inside of my job options, we have our delay and priority. We already pretty much talked about that. The next thing I want to talk about is the retry section, which is used mostly internally, but you can use it externally if you want. It essentially tells you how many times this job has been attempted. So let's say that we tried this job 3 times, this would be set to 3. This is also the maximum number of times we can retry this job before we fail it permanently. So if our maximum is 3 and our total attempts are 3, we're not going to re-add that job. And then finally, we have a delay inside of here, which is how long to wait before retrying a job after we failed the job. And this will increase over time. And I can show you that by looking at this. All we're essentially doing inside of our options, we're getting our retry options. We're adding 1 to our total attempts, which makes sense. And then what we're doing is we're taking our retry delay. Let's say we set this to 1 second. So it's going to wait 1 second before it retries this particular job. It's going to take that 1 second, and then it's going to multiply it by the number of times that we've attempted to do this job squared. So if we have tried this job 1 single time, it's going to wait 1 second and then try the job again. If we tried the job for 2 times and it failed both times, it's going to take 2 times 2, so that's 4, and it's going to wait 4 total seconds. If it has failed 3 times, it'll be 3 times 3. That is going to be 9. It'll wait 9 seconds until the next execution, and so on. Now, I do actually believe there is one slight problem with this code, and that I should actually be adding 1 to my total attempts right here. That's because total attempts right now is 0, and I'm adding total attempts to be 1 here. I want to make sure that this is also set to 1 to start. So essentially, if I've tried this job 1 time, this will be 0 plus 1, and then it's going to be squared. That'll make sure this actually works properly. That was just one minor bug that I had inside the code. But otherwise, really all that this does is if a job fails, it re-adds it to the queue, increments the number of times it's been done, and then sets it to delay so it does something in the future. That way it doesn't just do the same task over and over and over again and fail it over and over and over again. It waits a little bit before it tries it again. So this worker is not too complicated. We get a job, and if we don't have one, we wait for it. Once we have it, we process it up to our maximum number of jobs, and if any of those jobs fail, we just re-add it to the list to try it again later. We don't mess with anything else. We just get a job from the list and add it to the list. That's literally all that the worker does. Rather straightforward. The next thing I want to talk about is going to be the queue and the Redis adapter, because this is where pretty much all the bulk of the code for our application goes. So in order to create a queue, we essentially need to pass it in 2 different things. We need to pass it in the name for the queue, as well as any different options. And those options are going to be the retry attempts and the retry delay. So this is just like the default values for our job. This is the default retry attempts and the default retry delay. So every job by default, we will try 10 times and we will try a 1 second delay that exponentially scales as we retry it more and more. The next main function is that add job function. It's the function we're using pretty much everywhere to be able to implement our queue-based information. And inside of this function, we're taking in a job, but the important thing is we're not passing in any ID for this particular job, and all of our options are optional. So all of our jobs are optional for the options, and we don't have an ID that we're passing in, but we can pass one if we want. It's just optional. So essentially we pass in all of our core job information, which is going to be name and data, and then we have all of these options up here being optional, and our ID itself is optional. Now, the very first thing we do is we create an ID if we don't have one. I just make it a random UUID. You can do whatever you want. It just needs to be random in some way, because this ID is how we associate our job with everything. The next thing that we do is we check to see if this is past the total number of retries. So if our job options total attempts is greater than or equal to the maximum amount of attempts that we can do, we just return and don't add this into the queue at all. We could do some type of throwing an error or other things to be able to manage it, but I just completely skipped the rest of our code and did not add it to the array when we got to this point. The next thing we're doing is we're calling this.push. And this is a function that we actually define ourselves on each one of our adapters. And this function just says, hey, add this job to our list. And all I'm doing is I'm taking all of my options and setting default values for them. So by default, the delay is 0, the priority is 0, the total attempts is 0, and then down here, my retry attempts and retry delay are set based on these options up here if I don't pass them in myself. So all of this does is just set default values for my options if I didn't already pass them in when I created something. So for example, here I pass in a priority but no delay, so the delay defaults to 0. Here I didn't pass in a delay or a priority, so the delay and priority both default to 0. The next important thing to understand about this queue is that it has 2 other functions that well, technically 4, but really only 2. The push function, which I talked about, is for adding things to the queue where we save it inside a Redis or a database or whatever we use. And then the get or wait for function, which allows our actual workers to wait indefinitely until we get a brand new job, and then it pushes that out to them immediately. This is kind of the most important part of making sure that this is really performant. And then finally, we have a function to be able to get the length of our queue. So if we want to see how many items are in our queue, we can do that really easily. So now we get to by far the most complicated part of this entire system, and that is our actual adapter that works on this particular system. This extends our base queue class. So everything that I showed you inside of the queue is built into this particular class already. So for example, that add job function is built into this, and that add job function calls our push function right here, which is where a lot of complicated stuff happens. Now, if we look at our constructor, it's pretty much the same. We're passing along our queue name and our queue options. The biggest thing is that we have 3 separate Redis connections that we're creating. We have a blocking function here. This is just to make sure that when we connect to Redis, we're not also connecting multiple different times and getting multiple different jobs to different people. We're trying to minimize the amount of overlap. So when one thing is connected to Redis, it blocks all the other things from connecting to Redis. We have a non-blocking version because sometimes we don't need to block our connection. And then finally, we have this subscriber. This is what listens for when we add new items to the queue. And this will tell our workers, hey, we have something new. You should be able to work on it. So this allows us to make sure that only one worker ever connects to Redis at the same time. This makes sure that we can do things that we don't need to block for. And then finally, this one is to make sure that when we have a new job that comes in, it'll tell all of our workers that there's a new job available. Now, these final 2 functions down here for listening for expired jobs and checking for expired jobs is something I'm going to get to a little bit later, because right now it won't make sense until I explain the full process of how this actual queue works. Now, our get length function is super straightforward. It literally just gets the length of our active jobs queue. Straightforward, not too complicated. Our get or wait for job is going to be quite a bit more complicated. Same with push. So I want to skip past them so we can understand the working layout of our entire system. And you'll notice we actually have 3 separate lists of items inside of Redis. So instead of just having one list of active jobs, we actually have 3 separate lists. That way we can handle our active job, we can handle jobs that are delayed, and then we also need other lists to handle our delayed jobs properly in case our Redis system shuts down or we have some other type of error. So the very first list that we have is our active jobs queue. And as you can see, this is rather straightforward. We just pass it in our queue name and we append it with active, or prepend it with active, just like that. So this is just all the jobs that are ready to be executed, and we have them sorted by priority. So the very first job in the list is going to be the highest priority item that was added the essentially longest time ago. Next up, we have our delayed jobs list, and this is just all the data for our jobs. So this is essentially like a database table of our job information that is delayed. Because the way we store our delayed jobs is we store just the ID in our other tables down here. And then when we want to look up the information for those jobs, we reference this particular row or table or whatever you want to call it. This piece of memory stores the actual data for our job. So all the options, all the different data for like email and body of the email, all that is stored in this table based on the ID of the job. Next here, this is just going to be our delayed job IDs sorted by the time that they should execute. So every single job has a certain time that it needs to execute. Let's say we said our job is going to execute in 1 second. Well, that's going to be sorted in our list by execution time. So the one that executes in 1 second is going to come before the one that executes in 3 seconds, which is going to come before the one that executes a day from now, and so on. So this is just a sorted list of IDs based on this execution date. Then finally, we actually have a 4th list, and this list is the one that is all of the magic that is happening. This is again a list of our IDs, but instead of being sorted or anything like this, all that these do is they have an expiration date set to the exact time that they're supposed to execute. So if I have a job that's supposed to execute in 5 seconds, I set the expiration date for this particular key 5 seconds into the future. And then this function right here, listen for expired jobs, all it does is it listens to figure out, did we have a key expire? If we had a key expire and the key starts with this particular ID of our job list up here, if that's true, well, then what I want to do is I want to figure out what that job ID is, and I want to move that job to the active queue. So essentially all I do with this list is put my job in here and have it expire the exact moment that it's supposed to happen. Then once that job expires, or I'm sorry, this listing item expires, I go ahead and I say, okay, what is the ID of that job? I find the ID of that job. I reference the table that has the full data for that job. I get all that data for the job and I push it into this active queue right here. And this active queue is what every single thing in our actual database works off of. So essentially when we add something to the queue, we add it to the active queue by default. If it's a delayed job, what we do is we add it to this particular queue saying, hey, once this thing is delayed, expire the key. And when it expires, we reference this other table, which is where we put all of the information for the job to get the information for it before we add it into the active queue. Now the final table, this 3rd table, which just has our delayed IDs sorted by the execution date, the only reason this table exists is because if for some reason our Redis system crashes and we stop executing jobs. Let's say I had a job I wanted to execute in 5 seconds, and then my Redis system crashes before it gets to that job. 3 days later, I start back up my Redis system because I fixed the problem. Well, now I have a job that has expired because it's no longer in my system. It is completely expired, so it's not there. But how do I actually access that information? Well, it comes from this list. I can get all the items that I should have already executed but didn't because my system had crashed, and I can run all of those. And that's what this final function, check for expired jobs, does. Inside of here, what it does is it takes that particular list, this delayed job IDs, it finds all the ones that should have already executed by the current date, and it adds all of them to the active job list. So this entire function, as well as this entire table, is just a failsafe in case something in our system crashes and we stop listening for these expired jobs. It makes sure it still executes them even if they expire from our main list. So that kind of explains our for list system. I have a diagram that'll go more in depth into exactly what happens, but I want to talk a little bit about how actually adding the different jobs works. So let's go ahead and we'll minimize a lot of this down and we'll look at this push function right here. So the very first thing here is if the job has a delay, we go into this bigger, more complicated section. Otherwise, if there's no delay, we just straight up call add active job. And if we look at add active job, this is a rather simple function. It takes the list, which is our active job queue. It adds the item to our list at our current priority times -1. That way, if an item has priority 10, for example, it'll come back as -10. And since this sorts our items from lowest number to largest number, that means the higher priority we add, it'll flip that to a negative number, which will mean it moves it further in the front of our list. So the higher priority gets added to the front of our list because it gets turned into a negative number. That's how this particular system is working. That's the only reason we flop these numbers right here, because we sort from smallest to largest. So we add it to this sorted list. Now, if we move back up to the rest of this, if we look at what happens if we have a delay, well, what we do is we add to essentially all of our different lists. So first of all, we add our expiring key for our job ID. So we say, okay, this particular job ID will expire, and we specify what the expiration day is based on that delay. So it will expire in 10 seconds. That's what we add. The next thing we do is we add our job to this delayed job IDs queue, and this is the one that is like our backup list. So we add our job to the backup list, and we make sure that we put the actual time it should expire in the future. So we're saying this one should execute 1 second from now, so we add the exact date of that particular time. That way we can get this in case our system crashes. Lastly, we add our job information to this list of all of our job information. So for each job ID, we set the actual information of that particular job into our queue right here. So all we're doing is we're setting up the expiration, which we're listening to, we set up our backup, and then we set up our actual table to get the information, because otherwise all we're storing is the job ID, and this is storing our actual job data. And that's pretty much all that happens inside of this particular function for pushing, because as we know, down here, we're listening for expired jobs and moving all of our expired jobs over. So anytime a job expires, we just move it to the active list just like it was a normal job. So that already works for us. Now, pretty much the last thing that I want to look at is going to be all the way up here, the get or wait for job. And this is actually a relatively simple function. This is our blocking version of Redis because we only ever want to have one particular thing being able to access this at a time. We want to block it for other ones. And this is using the blocking version of zpopmin. Essentially, all that does is it takes whatever is the item that is next in our queue, sorted by priority and sorted by the time that it was added to the list. And it's going to get that information from our queue, and then it's going to get our data. And if we have data, particularly from this, because it returns it to us in kind of a weird array syntax, we just want the essentially second element in that array, we parse that data and we send it back so that we can process that particular job. So this function is actually surprisingly not very complicated because Redis has this blocking system built into it where we can just wait until something is ready. So we don't have to implement a lot of custom code for that because Redis just does all of that for us. But that's essentially the entirety of how this system works. So let's take a look at a diagram so it's a little bit easier to understand conceptually. So here we are with our full-on diagram that includes all 4 of our different lists. We have our main active queue. This works just like the simpler example where we take an item, move it into the worker, or add an item to the list. It works exactly the same. This is our active queue. Every time we have a job that we're done with, we move it into the worker, execute the job, and so on. If it fails, we add it back to the list. So now let's look at what happens when we have a job that we're adding to our system. So I'm just going to create a job, and let's say that we want to add this job into our system. Well, if this is a job that's not delayed, we just add it to the active queue and we sort it by the actual priority. So maybe if it's a high priority, it'll come somewhere into here. The rest of these jobs will move up, and this one will move into its place. It'll just sort itself wherever it needs to go inside of that list, or if it's low priority, it may just go to the very end of the list. Now that's the simple case. We kind of already talked about that. So what happens in a more complicated case where we have a delayed job? Well, when we have a delayed job, what happens is we take that job and we add it to that table that stores essentially a reference for all of our different jobs. So this is essentially associating a job ID with our job information. That's all that this table does. Just think about it as like a normal database table. You type in the ID, you get all the data for that particular thing. The next thing that we do is we take the job ID and we store it inside that delayed job ID section. What happens inside of here is we're putting an expiration date on this job ID. So we're saying, hey, this is a 1 second delay, so expire this key in 1 second. This list isn't sorted or anything like that. All it does is just expire the key after a certain period of time. Once that key expires, what's going to happen is it's going to take whatever job is associated with that, which is this one, and boom, add it down to the active queue. And that's going to work just like we want. But before we do that, we also are going to add a new row in this delayed list. So let me come in here. We're going to add a new row. This date is essentially the date that this is supposed to expire, and this is our job ID. And the whole purpose of this list is, again, if our system crashes, we can reference this list to find the things that expired themselves while our system was down. So let's say, for example, our system crashed and this key expired. Well, we have this entry right here that is expired. So what we do is we essentially say, hey, we have this thing that's expired. I want to find the job for it. And then boom, add that back to my active queue. So let's just bring that back a little ways. Essentially what happens is normally if our system works fine, this key will eventually expire. It deletes itself. Our program listens for that and it says, hey, this thing expired. Here's the job. I'm going to move this into our active queue and I'm going to delete the reference over here so we don't have any leftover references. Now, in the case that our program crashes, this is going to delete itself, but our program is not listening. So this whole onExpire section does not work. So what happens instead is when our program reboots itself, we loop through this list of delayed items, find out which one should have executed, in our case this one, we remove it from this list, and then we take the job associated with it and add it down to the queue. So that's why we have all these different tables for handling these jobs when we have delayed jobs. We have our active queue, which is simple when we have a non-delayed job. But when we have a delayed job, especially when we need to handle redundancy, we have these three separate tables. One to store our data, one to store the expiration, and one to store a backup in case something expires while our system is down. The nice thing for you though is if you're just using this as an actual user, you don't really need to worry about a lot of the complexity about why this works behind the scenes and how it works behind the scenes. And really all you care about is how do I initiate a queue, how do I add jobs to that queue, and how do I create a worker that executes jobs inside that queue. But understanding the underlying of how things work behind the scenes is not only super impressive to employers when you're trying to apply for a job, you can reference this information or include it in your portfolio in some way, but also helps with understanding why certain limitations are in place for your actual queuing system and how certain things work behind the scenes, just so you understand a little bit more. Because at first glance, some of these queuing systems seem really backwards, like why would you want to do that? It seems really slow and inefficient because of certain things. But now by understanding not only the reason for it with request times being quicker, but also understanding how the code works behind the scenes, it gives you an idea into, okay, I see why these limitations are in place because of all the complexities that go on behind the scenes that you may not have thought about before. And if you enjoyed this video, I have tons of other videos that deep dive into concepts just like this, such as authentication, authorization, feature flags, and so on. I'm going to link some of them right over there. And with that said, thank you very much for watching and have a good day.